this computer. There we go. Yeah, I'm going to post it today. I got to figure out how to do that. Okay, so lovely artwork there. Very good, very good. I did not have a chance just because we have so much stuff on there to make you guys a Google Doc worksheet thing. I apologize for that. I will do that next week because I did like that very much, how you guys sent me those pictures and stuff. It was cool to get a glimpse of, you know, who's doing what. But I'm going to tell everybody that you're going to want to have a piece of paper, notebook, something, because there's a lot going on today. So it looks, you know, deceptive there. There's only 3 assignments you guys have to do. They're a little bit longer because there's a lot of material in there. And it's not terrible. There's just, it's crazy. It all relates to this Pythagorean theorem. I'll show you. But this is what's going on this week. And because my brain is silly and not working, dealing with...
Yeah, we need to do a review on the new live session rules.
Oh, yeah. I have that. I have that next. That slide's coming up. I did not forget that one. Stop that, Logan. Okay. My children. Yeah, it's been a little crazy here for me. My husband's actually living in Wisconsin because, yeah, we're eventually going to be working our way moving there because of my mother being really sick. But I still get to work here, so you guys have to deal with me. Haha. Because I can still work at Blue Sky. Yes. All right. So, yeah, it's just been crazy. Nothing much, Nymphadora. Nothing much there. All right, this is our week ahead. Again, a little reminder, it's more like a parent-teacher open house. It's less like conferences and more like open house. So if you guys want to see me, I would love to meet each and every one of you in person. That would be so cool. I will be at Blue Sky along with your advisor and your counselors and all that stuff tomorrow. Yeah, why did I say the 28th? That is not the 28th. That is the 21st, Jen. 21st. So, yeah. So come on in. I'll have me there. I'll have some weird fidgets. I think that's what I'll bring.
Bring that little spider thing that you scream at.
Oh my gosh, you're right. My yelly thing?
Yeah.
I'm totally going to bring that. That is the greatest idea. I'm going to write that down. Hold on. That's a great idea. Okay, bring yelly spider. Do you guys hear my son there? He's going, ooh, ooh. Watching. That name is something. The yelly.
I posted the yelly on Facebook, and
Yeah.
Jen saw it and decided she had to get it for her kids.
Yeah, and it's the greatest thing. They spent the entire day just getting out all their rah at it. Don't want to get in trouble with my mom. Who's Disappointment? I don't know who that is.
I'm guessing Kaden.
Oh. Your boy. Yeah, that's what.
Yep.
That's the video that Allie posted. It's so funny, and then it really does kind of rush at you. It's a little like, oh my gosh, it freaked out my husband. But yeah, he doesn't like things that all of a sudden rush at him. He'll like high-pitched girl scream. It's pretty funny.
Oh, I would have loved to have seen that.
It's hilarious. Okay, we have to talk about, you know, just how we want to structure our live lessons. We kind of, sorry guys. It's a good episode. I can't deny him there.
What is he watching?
He's watching America's Funniest Home Videos.
Oh my God! I love that show!
Yes. He's just loving it. And of course they're home for snow day number 8. I can't blame him. I can't. It's funny, and he's being real good. My daughter's upstairs and is quiet, so I'm nervous, but I'll just kind of go with it for now.
Be very nervous.
Yeah. I don't know. Last time she got into my dry shampoo, and it was everywhere.
Oh, no.
Everywhere. But whatever. I'll go with it. Can always clean stuff up, right?
Right.
Okay, so big things we want to focus on is if you guys want to answer a question when I ask it, please use that raise hand feature. Sorry. Use the raising your hand feature that's found on the participant list. If you go to the participant list, there's ways to raise your hand, right? That's where it is, guys. Yes, okay. Yeah, and then don't forget to put your hand down if you're done with, you could raise and lower your hand that way. It just helps to make sure everybody gets a chance to answer questions. Also, we won't talk just while I'm talking. It's the same thing. It's just super distracting, and it is going to be a little distracting today when this guy's here, but I'll try and go with it. I can't help it there. But then let's just not also write on the board during the instruction. Just on the example slides, when I tell you guys, yeah, go ahead, great. But if it's an instruction slide or if we just get to it, don't write on there before we have a chance. I'm sorry, one second. We're kind of getting real hyper. Hold on. Okay, we get real hyper and can't help screaming. So, okay. So, yeah, that's it. Just, he really does like that show. Yeah. I'm used to it, And if I yell quiet, he'll yell quiet back at me. It's crazy. He's like a parrot. It's interesting. All right. So that's kind of the thing that we want to keep in mind, okay? And ordinarily, I would have a Google Doc and share it with you. I just didn't have a chance to do that because you're going to see there's a lot of like random stuff on here today. It's just crazy, but I will have it for next week. I just want to make sure we get through the instruction because I forgot to link the videos again. Smith Harold. I don't know what that is. All right. So we're going to get started. Again, please have a piece of paper or notes ready because you're going to need it. Extra disappointed. I like that. Okay, so first thing we're going to talk about is just some different terminology. First thing is tangents. A tangent line is a line or segment that touches a circle at just one point. So if I were you, I would draw the circle and then draw the tangent line and just label it tangent line. Something like that. The point of tangency, I can say it. The point of tangency is the point where the tangent touches the circle. So right here, that would be point A, point of tangency. Okay, other tangent lines could be a line segment or a ray as well. Either one, it's just that they touch the circle at just one point. And then that point where they touch the circle, that's called the point of tangency. Okay? Take a second, or as Dwight Schrute would say, absorb this knowledge. Right? Absorb this. Okay. But yeah, so that's one thing. We're also going to talk about secant lines and remember how last week we spoke about chords. So here's my circle. A chord is a line that touches the circle at 2 points that does not go through the center. So that's different than a chord. So this is a chord. And then a radius, remember, went from the center of a circle out to the side of a circle. Diameter goes all the way through and hits that center. XY is also a tangent. It's just a line segment because a tangent can be a line segment or a line. It's just got to touch the circle only at one point. It looks like that one's not drawn real well. I'm going to tell you because it looks like it's probably like going to touch at 2, but since it's just a line segment, we can say it's a tangent because it stops. Line segments stop there. So, what does my mother want? I just got this epic new iPhone. Oh, and my sister had a baby yesterday. I'm an auntie again. You guys want to see the baby? Look at the baby. It's in the camera. She's just the sweetest little thing. Look at that. Isn't that sweet? I love that picture. Oh my goodness. Oh yeah, definitely. Baby. I love that. Okay, so next one. Okay, a secant line is a line or line segment that passes through a circle in 2 points. So I drew that last chord incorrectly. That was my bad. Chord does not pass through the circle. The chord is that line segment. So this would be a better drawing of a chord. Oh, yeah. Babies are so sweet. We're going to go visit this weekend. I can't wait. So a secant is a line or a line segment that passes through a circle in 2 points. Yeah, I'm not liking this line segment thing. I think they're probably referring to the actual part. I think we should just stick with a line. I copied that from the textbook, but it's more confusing that way. I would think of a secant as a line that passes through the circle in 2 points, and a chord is like the line segment in the circle. And notice how it can go through the center. It's okay because it's passing through. So the inside part of that secant line would be the diameter, but because it's passing through the circle, it's okay for that to be a secant.
So what are we supposed to write for a secant?
Secant, you would say a line that passes through a circle in 2 points.
Can
A
you
chord.
give me a minute to rewrite it?
Sure, go ahead. Yeah, you got it. And the chord is the line segment part in that circle. Oh my goodness, he's so into the show. Oh, it's the Halloween jump scares one. That makes sense. So all the properties that we're going to deal with today are about this. And what's cool is that it all relates to triangles. So it's like you got to try and make this weird pattern fit into a triangle. Once you can do that, you're golden. So you're writing a secant is a line that passes through a circle in 2 points. That's it. And then I would draw the circle and maybe like this AB. That's a really good example of a secant. Any one of them is. Oh, yeah. Yeah. What's up, babes?
Really dry.
Yeah, we'll hang it later. All right, we doing good? Can I switch it? Oh, 1 second. Okay, you got it.
Oh.
All right, thanks for the thumbs up. Okay, so this is just kind of, I don't think you really need to write this down. I don't, but it's just good to know. An external tangent is a tangent outside the circles. An internal tangent is inside the circles. Okay, so you're thinking of a bicycle chain connecting gears on a tire, and this would be like a pulley system. So if it goes through two circles, kind of on the inside, it's called an internal tangent. On the outside, it's an external tangent. Okay, I'm going to tell you what to write down here because this is what we need to know. Tangents have two main properties. The first one, and this is how we can relate them to triangles, is tangents are perpendicular to the radius at the point of tangency. So if you look at this one here, okay, we have a tangent line. I like to label stuff because it really helps it make sense. Tangent line is right here, and this is our radius, and this is our point of tangency. So it says our first property here, tangents are perpendicular to the radius at the point of tangency. So what you could do is you could write that property down, or you could draw this picture, label those different parts, and then make sure you label that as a 90-degree angle, because that's how we can get triangles out of all this. Okay, so tangent lines are perpendicular at the point of tangency. And you're going to see it a variety of different ways. You're probably going to have to make the triangle. So what we would do, they would probably give us the tangent line, and they would give us this value, and we would have to figure out the radius or something. That's what we're going to be doing. So just know that where the tangent line connects to the radius makes a 90-degree angle because it's perpendicular. And you can see it either way. If you see it like here, you'll have to do some artwork to draw it in there. I see kitty. Oh, cute kitty. So here's our, we could draw in that radius. And then kind of helps us make that triangle there. But we would just know that there is our perpendicular, and then this, if we had our radius here, would be perpendicular. So where the tangent line hits the circle, it's going to make a 90-degree angle with the radius. Like write it down, you mean, in Fedora? Okay, no problem. I know, there's a lot of stuff. A lot. I'm suspicious I might have to make a video and send it out to you guys because I don't know, I don't want to rush. We'll see. We'll see. We'll get there. Not hard, just a lot. And I want you guys to get how to do it for the homework because I was a genius and forgot to put the videos in there. You're good, Allie? Good. Beth, you still writing? Okay, no problem. I love that you guys put your cams on. It's helpful. And if you don't, that's okay too. Oh, Hannah's here. Hi, Hannah. Hi, Lexi. Allie's here. Jana. Notice me, senpai. Done. Cool. Thanks for letting me know, guys. I appreciate it. Beautiful. There's lots of good stuff to write down here.
I just realized we have 2 Allies in this class.
Yeah, we do. Actually, we have you, Allie. We have Allie, Alexis. Oh, no, she doesn't go by Allie. She goes by Lexi. Oh, that's okay. No problem. Lexi, you and that computer, man. It's out to get you, I tell you. Yeah. That is just not fun. I get it. I had no internet at first this morning, and I was freaking out because I'm like, are you serious? I have to teach today. Come on. Oh. Awesome. Thanks, Beth. Okay. Okay, then property of secants. This is a really quick one. This just relates to the lengths. And I like how this one's presented. I would just write it exactly like that. Draw a quick diagram and then draw what that means. That's saying the length of PA. So when it's written like this, this stands for length of PA. So it basically tells you how to write up. Oh, that's annoying. Oh, hopefully, Lexi, we'll hope. Yeah, computers, they can be so fickle. Like, you think you get a good one, and then, yeah, I'm with you. But the length of PA, so this length times the big length is equal to this little length times the big length. So that's what they would do. They would maybe put numbers in there. They would maybe say, you know, this is 9 and this is 18. And if this is 2, they want you to find this length. So we would call that length x because we don't know it. And it just tells you how to set up the equation. PA, the little one, times the big one, equals the other 2. And then you solve. So that's the big thing. It just tells you how to set up that equation. And they would only do this if they want you to find those lengths of those secants. Okay? Do you guys got that written down? I didn't think the recycling guy would be coming. Oh well. That's okay. I don't recycle. No, I'm just kidding. I do. Okay, so this one, we would have to set up an equation to solve it. I don't know why it's called example 8. It's really example 1. I was moving stuff around. It was crazy. So for this one, to set up this equation, I would say the small length times PB, the big length. So we would call that 18 plus X. That's our big length. Is equal to this small length times the big length. Okay, and let me show that again because I thought they would give you the big length, but they don't do that because they're mean like that. The puppy. Oh, Logan, calm down. Goodness. Logan, gosh, that boy. So we would take the little length and we would multiply it by the length of the entire segment. And whenever you find the length of an entire segment, you would add them together. So we would call it 18 plus x. Well, we wouldn't say 18x because that would be if you're multiplying them together. So if I went this one times that one, that would be 18x. But since we adding them together for this other part, this big length, because this PB and PY, that stands for the big length. I just think of it as the big one. So whenever you need the big one, you got to add them together. No, it's okay. I'm glad you said it. Someone else will think the same thing. Trust me. So then we equal it to the small length on the other side times the big length. So we add them together. And this side, I would first add and then multiply. What do you get on that side? The big boyo. Let's raise our hands. We haven't had a chance to do that yet because there's so much like theorem stuff. What do you got, Nymphadora? The big boyo. I like it. Well, all we're doing, right, my question right now is 24 plus 16 and then times 16. What do you get? 40 times 16. Nymphadora, I love how you wrote that. Thank you. So 24 plus 16 is 40 times 16. What do you guys get? 640. Boom. You are right. So we've got 640 here. Now someone raise your hand and tell me, what does that property use where I would solve this side? So you got it. Got to give yourself credit there. Itty bitty baby. What do you think? What's that property?
Distributive property?
Yes, ma'am. What would I get if I did that?
You would get 324 plus 18x. Right?
Beautiful. You are
Okay.
right. Beautiful. Then we're just solving two-step equation there. Who wants to write it on there? How to solve the two-stepper. Wolfstalker? It's all you, Chica. I know, you're a pro at this stuff.
It was easier to raise my real hand.
It's okay. I saw
Go
it.
lay down, hon. Go lay down.
I heard that.
I swear, as soon as I have something to do, all the dogs want me.
Yeah, I hear their little claws click-clacking.
Okay, so I'm doing this 324 plus 18x, right?
Yep.
Okay. I think she was.
It sounded like that. Oh my gosh, it did.
Okay. So then 324 plus 18x. Okay, I get the x alone.
Right. I always like to put a square around my variable because it helps me see where my variable is.
Okay. So I'm probably doing this wrong already.
Yeah.
Subtract 18.
Is that our constant? Which one's our constant?
But
The number that has no variable. Get out of here.
oh, right.
It comes up and burps right here. Get out of here, Logan. Oh my goodness. Stop that. Go sit down.
Nope.
Oh my
Go
gosh.
inside.
Logan.
Just let me go inside.
Go sit.
Please let me go inside.
Go sit.
Please. Pretty please.
Sorry, 1 second.
Pretty please. Pretty please.
Yay, snow days. Okay.
Gotta love them.
All right, so shouldn't x be 17 or 8? Oh, it might be. It might be. So, yep, you're subtracting that 324.
Who's drawing?
Oh, I think Allie was going to do it. Yeah, you're not wrong there, but whoever's writing in green, go ahead and pause. You could leave it up there, but it's all good. We elected our official there. You're low-key crying. No crying. There's no crying in math. Perfect.
Nala apparently has the zoomies.
Oh, yeah.
Okay then. I gotta pull up my calculator. Hold on. 640 minus 324 is 316. See.
Yep, and then Allie is the one who should be writing right now.
X.
Let me get dressed.
Okay.
Jesus, you scared me. All of a sudden, I just walked into these two eyes.
The eyes are staring at you.
Well, she walked into the bedroom and Pongo was standing on her bed. $18x equals 316, so subtract 18.
When we subtract, what's the opposite
Oh,
of
divide.
divide? Yeah.
Why am I forgetting all of this?
It's not. It's because we're putting you on the spot. But you're doing awesome.
Ah.
Remember, all of you guys who are writing, I have the pen, and you're writing better than I do. So good job.
16 divided by 18. Oh boy, that gives us a fraction.
That's okay.
That's not me writing.
Oh, guys, come on. Let Allie write it. Sneaky monkey putting it in.
Guys,
Yeah.
we have rules for a reason.
We do. Come on, let her write. She's got this. And it's okay to have a fraction. It's okay. Or a decimal.
I said fraction, didn't I?
It doesn't matter. It's all good.
Okay, so I'm just going to round up.
Perfect. That is absolutely right. Okay. So that is how we do it. Questions on that? You'll have better numbers to work with when you guys do it. Allie, fabulous job. And again, guys, don't forget, if you're not the one writing, just let the person who we picked write. Yep, take it up for a second and then write it down. Ideally, we'd want to be writing kind of as Allie is solving. Or you guys are solving while Allie's doing it and then comparing. Yeah, definitely. So equation solving, great question, by the way. Once we distributed that number, okay, Casey did 18 times 18 to get the 324 plus 18x. We want to get that x by itself. So we are subtracting the constant. We always do the constant first, which is the number that has no x. So we subtracted that to get it to cancel. We got the 18x by itself. And then Allie did the 640 minus 324. And then she wanted to fully cancel out what's next to that x. So she divided to cancel out multiplying by 18. Remember, with equation solving, you're always doing the opposite. And then we get 17.6. And it, I'm going to say the numbers don't like, it doesn't look right. Like, this looks like it should be bigger to me, but I'm thinking the numbers. Someone just put numbers in there for this example. So don't worry about that. Yeah. So there we be. Equations. Yeah. All right. Now here is where we're going to start bringing in those examples that relate to those triangles. Okay, so right here they want us to solve for D. This is example 2. Yes, thank you. So notice how they told us the radius is 5. Okay, and then we have a tangent line. We have a line HG, which is touching the circle at one point there. Okay, so this is a radius. It's going from the center to the side of the circle. I also have a radius right here. Goes from the center to the side of a circle. So if this is 5, this is also 5. And the diameter would be 10. You are totally right. But key thing here, you'd think this stands for diameter. It does not. Yeah, and remember, we're not writing if Jen is writing. Okay, remember, let's stick to that. Even if it's logical, let's just let Jen write it because it's just clearer. So what we're trying to solve, it doesn't say, but we're trying to find the variable, find D, okay? So what we did is we copied this radius from here to the other radius because I know if this is 5, this is also 5. Okay, and then remember, I have a 90-degree angle in here, right? Do you guys remember where is my 90-degree angle? Where is it? I'm totally fine with someone writing the box in where I have a 90-degree angle. Sorry. He's listening. Okay. Shh. Yep. There exactly is a right angle and right there. This is the money. This is the one I want because this will help me solve it. Yay, Stella. Go, Stella. Go, Stella. Okay, so that is definitely my 90-degree angle. And we totally have a method to solve. Look at this. I have a right triangle here. We have a method to solve for the hypotenuse. Okay, yes, we do, but I'm going to pause. I'm going to pause because teacher did not instruct to write that. You're not wrong. You're not wrong, but you have to pause. Thank you. I appreciate it. I know it's hard. I know. But this is our Pythagorean theorem. You're right. That is our method of solving. Okay, so we have leg squared or the radius squared plus the tangent line squared equals that hypotenuse squared. And remember, you can use Desmos for this. You can. I know. Yeah, we got to stick to those guys. And I appreciate the person who was writing who stopped. I appreciate that. But let's just not even go there. So once I do this, I'm going to solve it. I get 5 squared, which is 25. 8 squared, which is 64, equals D squared. I add them together, 89 squared. Where are we getting 89 squared? Oh, you added this. Pfft, duh. I'm sorry. Yes, but you're right. We add those together. We do get 89 when we add them together. But see, here's the thing. It's not 89 squared. It's 89 equals D squared. Okay, and this is why we want, to wait for instruction on it. But your 89 equals D squared. So how do we cancel out that squared? What do we do? Itty bitty baby, what do you think?
You find the square root of it. Yeah,
Very
whatever
good.
they just drew.
Yep, we're going to find the square root of it, okay? So what is, someone on your calculator, do it and then raise your hand and I will call on you to tell me the answer. And remember, square root is just a button on your calculator. That's it. So we do the square root of 89. What do we get? You're going to get a decimal. It's all good. Jana, what'd you get? 9.4 is exactly right. And I appreciate you pausing and let's doing that because we want to hear from all of our friends. D is 9.4. Oops, that looks like a Q. 9. Oh my gosh, Jen. 9.4. And that makes sense because it's going to be longest side and that is the biggest value. So what you're doing with this stuff, guys, is you're trying to make right triangles. Seriously. Right triangles. That is your goal. How can I create a right triangle out of this? Okay? And you're going to see that example come up a lot. I'm going to kind of skip through other examples where it involves that. Okay, I have to clear. I apologize just for time. Oh, this is blurry. My apologies there. Okay, so this one here, we're again using some of our knowledge to be a little sneaky here. Okay, it's kind of fun trying to do this. So we're trying to make triangles. We got to use what we know. We know that where the tangent line intersects the circle, you're going to get a 90-degree angle. We know that. Okay. We can also kind of assume some things here. Let's look at this. We're trying to think triangles. Yeah, we know that's our 90-degree angle. You're totally right. But again, we're not. Yeah, it helps. I'm okay with that. That's fine with me. That's okay. But let's not write on the example. Okay, so this is our 90-degree angle. We could very easily figure out this angle here, but they don't want that. We want to figure out this one. So if we take a look at this triangle here, this little triangle, we know that this is a radius and this is a radius. So we have two sides that are going to be the same. So what type of triangle is that? No problem, Lexi. I will be done before that, I promise. What type of triangle is that that has two sides the same? Who can raise their hand and tell me what type of a triangle that is? Nymphadora, what do you think? Isosceles, you are right. So that means if this is 54, down here, this is also 54. Okay, and I'm getting closer there, right? So then we can figure out, I have 54 here, 54 here. I could figure out this angle, and we don't want to write on the diagram, you guys. Come on. We don't want to do that. We want to wait and listen to what teacher is saying because while you might get it, some other people might not. Thank you. I appreciate that. So we have 54 and 54 here. What would I do to figure out the length of this triangle? Someone raise your hand so you can tell me the procedure of what to do. Itty bitty baby, what would I do?
Okay, so because I can barely see the angles, but it's 54, 54. So
Right.
angle A, it equals up to 90 degrees. So you can subtract 54 from 90 degrees to get the angle that the smaller angle.
Yep.
And then with the angle, it's like because it's I don't know the name of the angle, but it's the other angle that's also 54.
Yep.
Since the I forgot the term, but it adds up to 180, so you do the same things and you subtract 54 from 180. And then since triangles add up to 180 as well, right?
Yep. You are right. Very good.
Yeah, you add the smaller angle and then the bigger angle you just figured out, and then you subtract those from 180 and then you find x.
Very good. Very good. And you know what's cool, guys, is Casey, she found a different way to solve it. I was going to have us find this angle here and then find the big angle, but you don't have to do it that way. You just have to use your triangle knowledge. So what Casey was saying is that we know this one's 54. If we go 90 minus 54, what is 90 minus 54? Can someone type it in chat, please? Nope, she has a cute little voice. She does. 36.
Yeah.
36 there. Perfect. So there's 36. And then down here, she was saying, and that was excellent, remembering it added up to 180. That's a linear pair, right? Very good, very good. We would take 180 minus 54 to get what this angle is. What would that be? What's 180 minus 54? 126. Thank you, Jana. Very good. So now we know that this is 126. This is 36. We do know, I like that. We do know that triangles add up to 180. So if we take 180 and if we subtract the 126 and the 36, that will tell us how many degrees are left for that angle X. What would that be? 18. Yeah, it's a tiny little angle. Very good. So you're just trying to make triangles. So that's what you guys are doing with these tangent lines. Okay, remember tangent lines make that 90-degree angle. And remember your Pythagorean theorem, and that'll help you get really far in this lesson. I know, it is. I apologize. There's a lot going on. Oh my gosh. But it's 18, and we're using triangles. That's what we're doing. Okay, we remembered, oh, this is a radius, and this is a radius. You have to try and see those triangles in the circle. And it's going to look crazy. But what I would do, guys, is I would look for two things first. I would look for where the tangent line intersects this circle, the radius there, in that one point that makes a 90-degree angle. Find that first. Then find your radius. Center to the side is radius. Center to the side is radius. And you know those sides will be the same. And then try and go from there. Find those two things, and it should help it be less crazy. Okay? Any questions on that? I did sound like that, didn't I? I like that. For that, students, is blah, blah, blah. No. Okay. Any questions, you guys, before we go? A lot of these other questions are like that. It's going to involve, and remember, if you're adding a side together, what would I label this side as? What would this side be labeled as? Yep. Yeah, very good. I would just call it 9 plus x, or the hypotenuse. The hypotenuse is going to be 9 plus x, or x plus 9, if you like that x first. Either one is fine. So that's good. So look for triangles in there. I'm definitely going to have to send you guys a video. See this example? It looks crazy, but look for 90-degree angles. Oh, thank you. Oh, thank you.
I have a question.
Yes.
So, with the videos you send us, do you want us to take notes and send you pictures of those too?
That is a really good question. I think you guys should take notes, but I'm not going to require it because you guys came to the live session. I don't want you to have to do more on your plate there. I am okay with you just using it to help you and then doing the homework. That's what I want you guys to focus on. Yeah. That's a cute picture there. So a lot of these are the same. So the videos that I will send are going to be about secant tangent lines and this little relationship here. That's kind of where I'm going to start. And I'll keep it separate. I'll say this video is about this. This video is about this. I will do that today. That way you guys, you know, You're probably going to need it to help with that homework. I don't want you to go through and do the homework and just kind of put the answers in there and redo it till you get it right, because that's not how you learn it for the test, remember? This circle stuff, you got to learn it. And it's not hard. It isn't. There's just theorems. That's it. So, if there are no questions for me, that is all I have for you lovely people. I thank you for kind of holding back a little bit on that writing, and we'll get there. It was pretty good. But thank you guys. Beautiful. I see it. You guys are amazing. Thank you. If you have no questions, you are free to adios. Thank you. I will send you videos today. I'll keep them short. They're just there to help. Bye. Yes. Oh my gosh, Kaden. Yes, we need to meet. Kaden, I'm a little full. Yes, Alexis, I have you 2:30. Kaden, I know you. I'm sorry. I'm getting buried in emails. Yeah, I am. It's been a crazy week. I'll get back on top. I have to get you on my schedule regularly. Could you do... Yes, I have you at 3. Does 3 work? Beautiful. It might have been 3:30 and I might have scooted people up. I gotta stop doing that. But yes, I have you on there. Oh, Frankie, are you still here? Frankie. Okay, well, I put Frankie at Thursday at 10. So do you want to do Kaden 11:30 Friday? Okay. Okay, I'm gonna put you 11:30. I do. Yeah, I haven't in a while, but I do. I'm actually gonna be getting my subscription card again. Have you started playing it? Okay, I'll have to look at. I've heard a lot of good stuff about that game. I have. Yeah, I have been I've been hurting. I can't talk today. Yes, I've heard a lot of good stuff about that game. All right, you are on my schedule for 11:30. Actually, can I make it 11? Okay, I'm gonna make it 11. I don't know why. Yeah, because I gotta get my daughter at noon. So yeah. Beautiful. All right. Well, you have a good day, and I will see you later. Bye.